Hello, welcome to everyone in this video. This is our lecture number 1 for the problem solution of electronics. Uh, we already discussed the theoretical part of this, that is circuit and network, in the lecture 1 in theoretical series. So if you want to watch this theoretical part, you can go through the description box, link are given there. And in this channel we actually provided the physics related theoretical and problem solution. If you want, you can go through the description box, or you can go through this channel. You will be get different playlist for different part of the physics for theoretical and problem solution. So let's start today's discussion. Actually, these three questions we given in the theoretical part, and I think you already try to solve this question and you obtain the solution. If there is a problem to get the solution, you can continue this to video to obtain the solution process, right? So let's start the question number 1 or problem number 1 he asked in the theoretical part of this circuit and network theory. First question says, consider the circuit as a given and apply the Thevenin theorem to find the current through this 4 ohm resistance. So this is the circuit given in this question, and you need to find out the current through this resistance, 4 ohm resistance, considering the Thevenin theorem or applying the Thevenin theorem. So you know, to apply the Thevenin theorem, you need to find out the Thevenin voltage and the Thevenin resistance. What is the Thevenin voltage? Thevenin voltage is nothing but the voltage across to this resistance in the open circuit. That means if you omit this resistance and measure the voltage difference at those two points, that is point A and B, you will be get the Thevenin voltage. So if we redraw this circuit considering this open circuit of this resistance, you can take that point A, there is a resistance and there are 15, so resistance and this voltage, and from A also they find out the resistance 5 and the negative side of this voltage. So I think you clear about this circuit. Now you need to find out the voltage across this point. So for finding the voltage across this point A and B, you need to know about this voltage, about this 5 ohm. How will we get this voltage? Just applying the Kirchhoff voltage law, Kirchhoff voltage law, KVL. In this loop 1, you can see that is the 10 into I1, 5 into I1, and this is the 15. So you will be get I1 equal to 5. So there is a voltage difference of 5. But you can see this current is flowing from that side to that one. So this is positive and this is negative. So this is positive, this is negative, and this voltage is minus and plus. So effectively the voltage across the AB will be nothing but 6 minus of this voltage. So this will be the 1 volt. So the voltage difference across the AB, that is the Thevenin voltage, is 1 volt. Now the Thevenin resistance is nothing but the resistance across this AB, sorting by sorting this voltage source, right? So if you sorting this to voltage source 6 and 15, the circuit will be like that. So you can see these two are parallel. So parallel combination of 10 and 5 is nothing but 10 by 3. So this is the Thevenin voltage and this is the Thevenin resistance. Clear? Will we get the Thevenin voltage and Thevenin resistance. So if you put this value, sorry, so if you put this value, the Thevenin voltage and Thevenin resistance, you will be get this current through this 4 ohm. So current is nothing but voltage by total resistance. So this will be the current which is passing through this 4 ohm resistance. This can be calculated by KVL, no problem, but you can also find this current using Thevenin theorem. That is the saying in this question. I think clear. If there is any doubt, you must comment in the comment box. Go to the next one. Next question says, consider the circuit of Q1, that is this circuit, and by using superposition theorem find out the current through this 5 ohm. So you need to find out the current through this 5 ohm using the superposition theorem. I think you know about the superposition theorem, already we discussed in theoretical part. So the final if you consider the voltage source for 15 ohm, 15 volt, you will be get the current across the 5 ohm, and if you consider the 6 volt, you will be get the another current. So in the superposition of these two current will be the total current at this figure circuit. So when we consider the 15 volt, this is 15, I think you, this is 15, okay. So this is 15 and this is short circuited of this voltage. So if you consider this loop current I1 and I2, small I1, small I2, so you will be get this equation, KVL equation, that is 10 I1 and this is 5 I1 minus I2, I1 and this is I2. So 5 I1 minus I2 equals to 15. So you will be get this equation, and in loop 2 you will be get 4 I2 and 5 I2 minus I1, and there is no voltage source, so this is 0. So you will be get this one. So you will get this I2 equal to 5 by 9 I1. Put this value of I2 in this equation, you will be get this value of I1. After getting this value of I1, you will be get I2 value using this equation. So you will be get I1 I2. So capital I1 is nothing but small I1 minus small I2. Small I1 minus small I2. So if you put this value, you will be get finally 6 by 11 ampere. This is the current flow due to this 15 voltmeter, 15 volt voltage source, right? And if you consider this 6 volt, if you consider this 6 volt, now the same thing, if you consider loop current I1, loop current I2, and this effective current will be taken as I2. So using this KVL in this loop 1, you will be get 10 I1 and this 5 I1 minus I2 equals to 0 because there is no voltage source. So you will be get 3 I1 equals to I2. 3 I1 equals to I2. Okay. And in loop 2, you will be get 4 I2 and 5 I2 minus I1, and this is minus 6 because this arrow taken as that direction and this current flow from the positive direction in the opposite. That's why this is minus 6. So you will be get this final equation I1 equal to minus 3 by 2. So you will be get I2 also. So the capital I2, that is the current effective due to this 6 volt, will be like that. So you will be get this I2 also 6 by 11, and this is 6 by 11. So final total current through this 5 ohm equals to 6 by 11 plus 6 by 11, that is 12 by 11, that is 1.091 ampere. I think clear. If there is any doubt, you must comment in the comment box. Next question. Next question says consider the circuit with V1, V2, R1, R2 is zeros, capital R1, capital R2, capital R3 given. So this is the circuit where the value all are given. Using Norton's theorem, find the current through this resistor R3. So you need to find out the current through this R3 using Norton theorem. So you know, for the Norton theorem, you need know about the Norton current and the Norton resistance. Norton resistance is nothing but equivalent to Thevenin resistance. That is the resistance of this circuit across these 2 points when the source are sorted, right? So if you consider the current through this is IN, Norton current is nothing but when this load is sorted out, the current flow this in this path. So Norton current is I. So you take this I1, capital small I1, and this is small I2. So the KVL using this loop 1, you can get that is R1 I1, capital R1 I1 equals to V1, and R1 small R1 is 0, so you will be get I1 equal to V1 by R1, that is 3 ampere. So for this loop, the I1 current equal to 3. In loop 2, you will be get this equation I2R2 equal to minus V2, so you will be get minus 3 I1. So Norton current is nothing but I1 minus I2, that is 6 ampere. So you will be get the Norton current. Now you need to find out the Norton resistance. Norton resistance is nothing but the resistance across this point when these sources are sorted. So when these sources are sorted, you will be get this relation, and you can see along across this point AB, this R1 and R2 is nothing but in the parallel condition. These two are in the parallel condition. You will be get this parallel combination. You will get 24 ohm. So the Norton equivalent circuit equals to, this is the Norton current and this is parallel resistance, Norton resistance. So you need to find out the current across this. So the voltage across that one is nothing but the Norton current into effective resistance, that is these two are in parallel combination, and 24 parallel is the 12, 24 is 12. So this is the voltage. So current through this R3 is nothing but voltage by resistance, so 3 ampere. So I think clear about the solution of this question. If there is any doubt, you must comment in the comment box. So that's it for today. This is all about me, and this is my contact detail. You can connect with me with this Telegram channel. This is my online platform. And this is my YouTube channel details. Go to this channel, you will get different free related videos, some mathematics like this session. If you learn something from this session, share this video to your friends, either he or she also get benefit from this video. Subscribe this channel if you need this channel. Those already subscribed, thanks for subscribing. Press the bell icon to get notification of upcoming video. So take care, we'll meet in the next video as soon as possible. Thank you.